Today's lesson is on section 2.1, use integers and rational numbers. These are both two different sets of numbers that we're going to talk about during the year, and we should know what integers are, we should know what rational numbers are, and there are a few other sets we're going to talk about as well. That just happens to be the title of this section. Whole numbers are also included here, and as you can see, I've got those three sets, the names of those three sets listed on the left here. I'm going to list kind of what those sets look like, and it'd be a short definition for what kind of numbers go in to those particular sets. First one we'll start with is whole numbers. Whole numbers is a nice one you can actually make a little list with. Whole numbers, sometimes I'll ask students if they know anything about any of these sets, and whole numbers is usually one they know a little bit about, or can kind of remember. They remember that it starts with, it's all the numbers that you can count, kind of like 1, 2, 3, 4, 5, and on up, all the way up as far as you can go. And then one thing just to remember, that the first number actually for whole numbers is 0. Okay, so it starts at 0, and then essentially is just the numbers you can count, positive numbers you can count, all the way on up, all the way up to infinity. So 1,000 would be a whole number. 82,561 would be a whole number. Okay, 2 billion would be a whole number, and every number after that too. Any number that doesn't have a decimal, and it's like numbers that we could count up to, all positive numbers. We'll often make little definitions then during this lesson. I'll ask the students to make them, but the one we come up with most often is numbers that don't have decimals. And are positive. We usually say something to that effect about whole numbers. Also, just remember 0 is the very first one, but and sometimes I might have them add that in there too, but we'll just kind of keep it short right now. Numbers that have decimals and are positive. And then if you want to make a note about 0 as well, 0 is the very first one. Integers, the next one, kind of the next step up, and we'll see how all these sets fit together. We'll start talking about integers, and students will realize that, well, these numbers are actually integers as well. At least they can fit in that category. The best or most specific name for them is whole number. But even numbers like 0, 1, 2, 3, 4, 5, and so on, they're actually all integers. They fall in that category as well. What integers adds to the mix is negative numbers that we can count. So -1, -2, -3, -4, and so on, all the way to negative infinity. So integers, sometimes we'll start off almost with the same definition here again. And again, if you're taking notes along with me, these would be things you would write down. I'd want you to put the list of these numbers, and also what I have in red here is a small definition. So integers are numbers that don't have decimals also. But they can be positive or negative. Positive or negative numbers. My E kind of got cut off there, but that's what we know about integers. So as you can see, and I'll have a little diagram that kind of shows how these fits together as well, but whole numbers, again, 0 all the way up. Integers include whole numbers, and they also include a set of negatives over here as well. So that set's even bigger than whole numbers because it includes all the whole numbers and then some additional numbers as well. Rational, same kind of thing. If I wanted, I could start off by listing these numbers as well. All these numbers are rational as well. They fit in this category. 0, 1, 2, 3, 4, -1, -2, -3. All these numbers fit in there as well. But rational also starts to add some other numbers, and I'm not going to make these fit in here because there's an infinite amount of them, but I'm just going to list some other examples that can work in here too. We start to add in decimals now into rational numbers. So stuff like 3.5, 0.5, and then it makes sense if we're talking about rational numbers being decimals. Well, that means they must also be fractions, correct? Because 0.5, if I want to write it as a fraction, that's just 1/2. If I want to write 3.5 as a fraction, I could write 7/2, or like a mixed number, like 3 1/2 as well. So realize that in rational numbers we start to add in decimals, fractions, and they could be positive or negative as well. So I could also list up here, just kind of throwing some other numbers up here, negative 2.4. Okay, there's another example of a rational number. Okay, or again, negative 5/7, a negative fraction. One other type of decimal I haven't put up here yet that's still a rational number too. You can see these decimals right here. Decimal numbers can be rational, okay, certain ones. You can see these ones right here that I have so far are all ones that we call terminate, or ones that end, okay? Negative 2.4, 0.5, 3.5. Just one more example here. 49.125. And then the decimal stops. There's nothing else after that. Those are all called terminating decimals. Decimals there where the number does eventually end. There's a type of number that's rational that doesn't end, and we've seen this before too. Something like 0.3 repeating. That means this number is just like 0.3, 3, 3, 3. It goes on forever, an infinite amount of threes. These also are rational numbers. If it's a repeating decimal, it also is rational. It fits in that category. On this page, I've got a little diagram of the numbers I've been talking about so far. Rational numbers, integers, whole numbers, they're all right here. And I want you to copy this in your notes also if you're taking notes along with me. Here are the three categories we're talking about. Whole numbers, integers, rationals, the ones I've talked about so far. And again, this diagram shows how they fit together. So there's the kind of in the inside, the yellow circle there, there's whole numbers. We talked about those first. 0, 1, 2, 3, 4, all the numbers you can count, positive numbers, starts with 0. So let's think of all the numbers that are whole numbers being inside this yellow oval right here. Okay. Well, if those are all the whole numbers, we said that integers, going back to that previous page, okay, we said that integers, remember, they include the whole numbers, right? Here are all the whole numbers, but we just also include all these negative numbers as well. So that's why now this larger green circle, the whole numbers are inside of that because they're also considered integers. They fall into that category. But integers also include these numbers that I got in here, -1, -2, all the negative numbers, correct? So that's why those numbers are also inside the yellow numbers or whole numbers. They're also inside the integer category because they fall under that heading. The best name for some of these numbers like 1, 2, 3, 4, the most specific name is probably a whole number. But just know it also fits in the category of integers as well. So that's why we kind of keep growing. We keep adding something to it to get to the next level. That's what happens with these. Then we've got the biggest level so far that we talked about, the rational numbers. Rational numbers, again, notice that whole numbers and integers are in this big orange box, the rational numbers. So let's say all the rational numbers are contained in here. Okay. Well, whole numbers and integers are also considered rational. They're also in that group. But then we start to add numbers like we talked about, like decimals that end, okay, or even negative decimals that end, or anything with a decimal, or repeating decimals or fractions. All those types of numbers are included in the rationals as well. So again, each set just adds a little bit more. Each set gets a little bigger. But the other sets are still inside or contained in that category as well. Before I go too much further, I still want to give you the definition of rational numbers. I gave you a small definition for whole numbers and integers, kind of one that we make up in class though. For rational numbers, I'm going to give you the exact definition, or what they say in the book. Rational numbers. Any number that's rational is a number that can be written in the form a/b. And what does that mean? Well, that just means written as a fraction. So if I can write a number as a fraction, it must be a rational number. So we talked about fractions themselves. We had on that previous page like 1/2. Well, that's a fraction, so that must be a rational number. What about a number like, well, let's say some kind of decimal like 0.25. Well, a number like 0.25, there's a way to write that. There must be some way to write that as a fraction if we're saying that it's a rational number. And 0.25 is kind of a common one. You may remember that's actually just the fraction 1/4. So yeah, that one also is a rational number. What about all these other numbers we talked about? Going back to the chart here for a second. We talked about numbers like the whole numbers in here and integers. What about those? What do we mean? Can we write those as a fraction? Well, there's a way to represent them in fraction form is what we're saying. So take a number like 4. And we'll talk about this in class, but Students will remember sometimes, how can I write the number 4 in its fraction form? Well, that's just any whole number. You can just put it over 1, and there's 4 in its fraction form. So yep, that's how we know it falls under rational numbers as well. And same thing with a negative number, negative 11. Okay, if I want to write negative 11 as a fraction, I can just put negative 11 over 1. So yep, that checks out. It's a way I can write that as a fraction and put it in its fraction form. It must be a rational number. One more I'm going to put up here. And some people talk about repeating decimals and maybe not sure how to write those in fraction form. Well, there's kind of a method to it. We probably won't get into it this year, but I can just show you an example that it does work. Think about that one repeating decimal we had up here before, 0.3 repeating. That just means 3's on forever. Again, this one also, if it's a rational number, there must be a way to write it as a fraction. And yeah, this one does have a fraction form. It's kind of another common one we see. It's the fraction 1/3. So even repeating decimals or decimals that stop, those are all rational numbers. Going back to that chart for a second, I still haven't talked about two other things. I haven't talked about the numbers in the big red box here on the right side. These are called irrational numbers, and we're also going to talk about those today. And then just one thing to note, we'll bring this up again in the future, but all of these numbers are called real numbers. So whether they're in the orange box, the red box, or one of the ovals, everything falls under the category of real numbers. That's the numbers that we're going to know as 8th graders. We will know all the real numbers that are possible. But right now we're going to talk about irrationals. I'll come back to reals in the future sometime, but irrational is the one box I haven't talked about yet. So irrationals, you can see there's some decimals in here or some other kind of numbers. We talked about rational numbers, especially the decimals being ones that terminate, like 3.5. So that's a decimal that just stops. Or 0.3 repeating. Again, it repeats some number over and over and over again forever. Well, irrational numbers then kind of do the opposite of both those things, as you can kind of see from an example here. And I've got a couple notes that I want you to write down about irrationals. If there's kind of it's not really a definition, but here's what happens with irrational numbers. Well, we talked about rational either stop or they repeat a pattern. Irrational numbers don't do either of these two things, and that's how we know they're irrational instead. Irrational numbers are also numbers that go on and on forever. They don't stop, they go on and on forever, but they don't repeat any kind of pattern. The digits never fall into some pattern where it's always just the same numbers over and over and over again. So as I've got this example up here, I just kind of made up a number, but this one right here, 0.21592105472638201 ... That means the ... is saying that number goes on and on forever. And I don't see any kind of line over into the numbers like I have up here for 0.3. Okay. Remember, again, here's what it looks like if some number starts repeating, 0.3 with a line over it. But in this case, there's nothing like that, so that's how we know that none of these numbers repeat any kind of pattern. That's what irrationals look like. There are two main types that we're going to see this year have to be aware of. One of them is pi. Pi is an irrational number that never repeats a pattern and goes on and on forever. And the other types that we need to know is square root numbers. And sometimes you'll hear me, the students will hear me say this in class, but square root numbers that don't give you something nice. I'm going to give you an example of what I mean by that. Square root means some number times itself gives me the number under the radical. Well, square root of 25 is just 5. Square root of 36 is just 6. But there are many numbers in between that that we can take the square root of. So let's say like a number like square root of 30. Taking the square root of 30 doesn't give us some nice whole number. Square root of 30 isn't a, again, I'll say nice, but yeah, that's probably a better way to say this. It's not a whole number. It ends up being some kind of decimal. Whenever you take the square root of some number that doesn't give you a whole number, like 30, it's going to be an irrational number. Punching this in the calculator, here's what I get. 5.47722555750 ... Again, there's a few numbers that kind of double in there, but there's no real repeating pattern like 0.3 repeating where it's 333 over and over again. Or again, some other number like 0.12 and then the 12 over and over and over again. So it's not a repeating pattern. This is how I know it's an irrational number. And students sometimes they'll punch numbers in their calculator like this and they'll think that it ends at the end of the calculator, but no. If your calculator could go on and on forever, it would show you all the numbers that keep going for square root of 30. It does go on forever, that decimal, but there's no end to it. So that's how I know it's going to be an irrational number. Anytime we take the square root of some number that doesn't give us something nice, that's when we're going to get an irrational. So square root of 7 will be an irrational. Square root of 8 will be an irrational. Square root of 9 is 3. So there are some square roots that are going to fall in there that will be whole numbers, but otherwise square root numbers that don't give us, again, something nice, or I should say don't give us a whole number, those are numbers that are going to be irrational. Last thing I'm going to do is here in class we're going to look at all these numbers on the board. I put a bunch of random numbers up here, and I'll have students come up and circle which ones are whole numbers, which ones are integers, and maybe which ones are irrationals, just kind of picking out some of those groups. Right now, and if you're following along and taking notes and doing the lesson with me, then try to pick those numbers out yourself right now. Pause the video and see if you can pick out the numbers that are whole numbers, the numbers that are integers, and then also the numbers that are irrationals and rationals. But going into it here, again, what we might do in class, I'll ask students to come up and circle some of the whole numbers. There should be 3 whole numbers you should be able to find. 0 is the very first whole number, so we'll circle that one. 58, again, that's just a big number that we can count, but no decimal, it's positive. That's another whole number. And there's one more whole number on this board kind of disguised, because right away, it's got a square root on it, but it's this one right here, square root of 144. The square root of 144 is a whole number. It ends up being 12. So that one also I'd say is a whole number. Circle. So all our whole numbers are in blue. Then I'll ask students to come up and circle all the integers that they see. Right away, students might think there's only one integer up here. Negative 12. That one definitely people can usually pick out. Negative 12 is an integer. Some people also try to go to negative 3.5, but remember, integers don't have a decimal. They're negative, okay? They can be negative numbers, but they don't have a decimal. But now usually I'll keep asking students, well, there are more integers up there. Can you find any other integers? Negative 12 is one of them, but there are some other ones. There's actually 3 more, and it's ones that we've already used. Remember, these numbers also fall into the category of integer. 58, that's an integer because it doesn't have a decimal. 0 is also an integer, and so is 12. So eventually I'll get students are convinced them that those also fit in the integer category, so those we ought to circle as well. Then we'll talk about the numbers that are irrational. I'll jump to the irrational ones. And we start to remember pretty well pi is irrational. A decimal that goes on and on forever. Doesn't repeat any kind of pattern. Square root of 24. Square root of 24 is not a whole number. It's not a nice number. Square root of 25 is 5. But square root of 24 is going to be 4.9 something something something. And it'll go on forever and not repeat, so that's an irrational. And also square root of 8/7, that fraction, that'll still give me some kind of irrational as well. So we'll just kind of pinpoint some of those. Everything else up there must be some kind of rational number. And again, so rational means you can write it as a fraction. Well, then 7/29, yeah, that's a fraction, so that must be irrational. Any fraction has to be a rational number. And same thing with mixed numbers, because we can change them into fractions. Then we talked about decimals that end. Those are rational numbers. So 0.25, 98.5, 0.5, those are all rational. And rational numbers are repeating decimals as well. And if students remember, we'll then also circle these two, right? Negative 12. It's an integer, but it falls under that rational category as well. So does 58. So does 0, and so does 12.